Greetings and welcome to eCraft. In this video, we will show you how to create colorful light using the RP2040 board and the built-in Neopixel RGB LED of the RP2040 carrier board. In this video tutorial, you will learn how to create a simple project to design decorative lighting and control it through a Bluetooth app on your phone. While the video features a single Neopixel, you can easily customize the sketch to control an entire Neopixel RGB strip. Let's begin with an example sketch where the pattern and color of the Neopixel LED changes when a button is pressed. I'll demonstrate how to modify this program to control the lights using a soft button on your Bluetooth app, which you can run on your mobile phone with ease. You may find it helpful to watch some of the videos available on this channel, which introduce the RP2040 Pico board and Citron's Pico board. As I mentioned earlier, you can quickly get started with utilizing the dual-core feature by installing a third-party RP2040 board package from Earl's GitHub page. The built-in Neopixel LED of the Pico board has an intelligent digital chip WS2812B. The digital input signal of this chip is wired to the GPIO28 of the Pico board. To get started quickly, open the example sketch button cycler from Adafruit library. If you do not have this library already, you could search Adafruit Neopixel in the library menu in the IDE. This sketch allows you to control the pattern and color of the Neopixel using a button connected to RP2040. Before downloading the sketch onto the Pico board, make sure you have correctly defined the pins in the code. I have adjusted the button pin, pixel pin, and pixel count parameters to match my hardware. Keep in mind that you can use a Neopixel strip by simply adjusting the pixel count. Since the sketch was written for WS2812B, I didn't change the default Neopixel strip object settings. Within the setup function, the Neopixel strip object is initialized, and the button input is defined as an input pin with a pull-up resistor. Until the button is pressed, the button pin will read a high signal, and upon pressing, the signal will be driven low. Moving on to the loop function, it detects a high-to-low transition on the button pin. Upon detecting a button press, the state machine transitions to the next state out of a total of 9. 4 functions are defined to generate various LED patterns. Allow me to walk you through the rest of the code. Let's take a moment to learn about the non-blocking push and pop functions provided by Earl's software package. These functions are different from the blocking push and pop functions in that they do not halt the execution of the program if the FIFO is full during a push operation or empty during a pop operation. Instead, they return a Boolean true or false value to indicate success or failure, respectively. Note that the use of blocking push and pop functions are introduced in the previous video. We're all set to add Bluetooth functionality to the Neopixel code. To do this, I opened the SerialBT example sketch and used the Bluetooth serial library called SerialBT. This library comes installed with the RP2040 board package. I am planning to split the Bluetooth and Neopixel operations between the two cores of RP2040. The setup function for core 0 only initializes the SerialBT object. In the loop function, if the character sent over Bluetooth matches the capital letter C, then core 0 will push a value into the FIFO using a non-blocking push operation. Depending on whether the push operation is successful or failed, an appropriate message will be sent over Bluetooth. Core 0 is done. The Neopixel code used for Core 1 is copied as is, but the functions must be declared before the setup and loop functions to avoid compilation errors. Please note that the suffix 1 is added only to the setup and loop functions implemented for Core 1. Apart from that, the only modification made was to disable the button press detection function. Instead, the Neopixel state transition is triggered only when Core 0 has pushed a value in the FIFO. I included a non-blocking pop operation in loop 1 to prevent the FIFO from becoming full. The rest of the Neopixel code remains unchanged. After double-checking for errors, we are now ready to upload the sketch to the Pico board. The code has been uploaded. Next, we need to open the serial Bluetooth app on our mobile device and configure a button to send the hex value for capital C. You can find additional videos in this channel that demonstrate how to install this simple serial Bluetooth app. Pair RP2040 as a Bluetooth device and open the serial Bluetooth app. Connect the device to start playing. Enjoy!